Stop what you're doing and look at the date on your phone right now. It is March 2026. 8 days ago, something happened in the shadow of Jupiter that should have halted every television broadcast and triggered emergency sessions at the UN. Instead, what did you get? Silence. A calculated, deafening silence from the very institutions that claim to be the gatekeepers of our reality. They are betting that you were too distracted, too tired, or too trusting to look at the raw data coming off the servers. But the physics don't lie, and the math just committed suicide. We were told 3I-Atlas was just a rock, a billion-ton chunk of primordial ice from another star. But rocks don't survive what happened on March 16th. Rocks don't navigate the most violent gravitational meat grinder in our solar system with the precision of a scalpel. If you still believe the official narrative after what I'm about to show you, you aren't just skeptical, you're choosing to be blind. Let's get into the violence of the physics, because this is where the lie falls apart. On March 16th, 3I-Atlas passed within 33.3 million miles of Jupiter. To a human, that sounds like a massive distance. To a physicist, that is a journey into the heart of a gravitational furnace. Jupiter is 318 times more massive than Earth. It is a planetary beast whose gravity doesn't just pull, it stretches, it compresses, and it wrings objects out from the inside. They call it tidal forcing. Imagine taking a wet towel and twisting it until the fibers scream. That is what Jupiter does to anything that gets too close. We have watched it happen. We watched comet Shoemaker-Levy 9 get shredded into 20 pieces by these exact same forces. Natural objects, rocks, ice, dust, have a breaking point. They have a limit to how much internal stress they can take before they fracture, outgas, and disintegrate into a cloud of debris. But 3I-Atlas, it didn't flinch. There was no fragmentation. There was no cloud of ice. There was no signature of a dying rock. It moved through that field of 318 Earth masses as if it were made of a material we haven't even named yet. It didn't just survive the stress test. It ignored it. And then there is the number that should make your blood run cold. 33.2 million miles. That is the Hill radius. It is the exact mathematical boundary where Jupiter's gravity becomes more powerful than the sun's itself. If you cross that line, you belong to Jupiter. If you stay outside it, the sun keeps you. 3I-Atlas skirted that line within 0.1%. Think about the scale of the solar system. Think about the speeds involved. Thousands of miles per hour. Missing a cosmic boundary by a fraction of a percent isn't good luck. It isn't a statistical anomaly. It is navigation. It used that exact boundary to execute a gravitational slingshot, stealing momentum from Jupiter to accelerate itself out of our solar system on a trajectory that was perfectly calculated to maximize its exit velocity. Nature doesn't play with margins that thin. Nature is messy. Nature is random. Technology is precise. But the real smoking gun, the thing that is keeping the heads of space agencies awake at night, is the mass. We finally have the confirmed estimates, and they are impossible. 3I-Atlas has a mass of approximately 1 billion metric tons. For context, the very first interstellar visitor we ever saw, Oumuamua, was only about 10,000 tons. That means this thing is 100,000 times more massive than the only other visitor we've ever confirmed. Now, apply basic logic. In every model of how the universe builds things, smaller objects always outnumber larger ones. For every 1 billion ton mountain, there should be millions of pebble-sized rocks, thousands of house-sized rocks, and hundreds of Oumuamua-sized rocks. If 3I-Atlas is a natural object, our solar system should be crawling with thousands of smaller, natural interstellar visitors every single day. The Vera Rubin Observatory just came online in February. It was built specifically to find these things. It generates 10 million sky alerts every single night with the most sensitive cameras ever designed by human hands. Do you know how many of those smaller, natural interstellar rocks it has found in the last 30 days? Zero. Not a single one. This is a mathematical impossibility. It's like walking into a forest and seeing one giant 1,000-year-old sequoia tree, but not a single blade of grass, not a single bush, and not a single sapling in the entire world. It doesn't happen. This leaves us with a reality that the scientific community is too terrified to admit. 3I-Atlas does not follow the laws of natural distribution because it isn't a natural object. It's an outlier, so massive and so isolated that that it defies the very definition of an asteroid. And don't think for a second that we were the only ones watching. Every major asset we have in deep space was focused on that flyby. The Juno spacecraft, which has been orbiting Jupiter for years, was repositioned. The ESA's JUICE mission was watching. Every ground-based array from Chile to Antarctica was locked on. They have the high-resolution images. They have the spectroscopic data that tells us exactly what's inside that glowing crack we're seeing on the surface. They're sitting on it. They're verifying it. They're processing it. Meanwhile, the object is already moving away, carrying its secrets into the deep dark. Harvard's Avi Loeb warned us about this weeks ago. He calculated that if an object like this wanted to, it could release a probe or a seed during a flyby that would use Jupiter's gravity to park itself into a stable orbit. He called it a clear technological signature. Nature doesn't park objects. If you find a car sitting in a parking lot, you don't assume the wind blew it there and the gravity of the pavement held it in place. You assume someone drove it there and turned off the engine. If we find a new, dark, city block-sized object in orbit around Jupiter in the coming months, the game is over. That isn't a moon, that's a station. And just when you think the story has peaked, look at the sky. Because as 3I-Atlas exits, a second interstellar visitor has just been detected. It's on a sun-grazing path, moving with the same anomalous speed, displaying the same lack of outgassing, and arriving in the exact same window of time. Two massive interstellar anomalies in 1 year after billions of years of nothing? That isn't a coincidence. That is a procession. It's a deployment. The institutions will keep telling you it's just a rock. They will keep telling you that the secrets of inner life, or whatever they want to label this phenomenon, are just natural geological processes we don't understand yet. They will use big words to hide the fact that their math is broken. But you saw the trajectory. You saw the mass. You saw the silence. Jupiter didn't just bend a path on March 16th. It acted as a diagnostic tool that proved 3I-Atlas is a machine. Drop a comment right now. Are you going to wait for a government press release that will never come, or are you looking at the same evidence I am? We are living through the most significant event in human history, and they are trying to bury it under a pile of standard astronomical procedures. Don't let them. Share this, talk about it, and keep your eyes on the data, because the second object is getting closer every hour, and this time it's headed straight for the sun. Would you like me to create a pinned comment for this video, designed to spark a massive debate in your comment section to help the video go viral? James Webb just scanned 3I/Atlas, and it's not an asteroid. 3 weeks ago, the James Webb Space Telescope was quietly redirected. Not scheduled maintenance, not a routine observation window, a target of opportunity request, the kind reserved for things that don't wait. The target was 3I/Atlas, and what the infrared data came back with has split the astronomy community into two camps: those who think it changes nothing and those who think it changes everything. Here is what we knew before Webb looked. 3I/Atlas entered the solar system on a hyperbolic trajectory, meaning it came from outside, meaning it is not ours. It was moving at 67 kilometers per second relative to the sun. Fast, but not impossible for an interstellar object. It had a visible coma, a halo of gas and dust, which is exactly what a comet looks like. Case closed. Interstellar comet. File it next to Oumuamua and Borisov and move on. But Webb doesn't see what your eyes see. Webb sees heat. Webb sees molecular fingerprints. Webb sees the chemistry of a thing at the atomic level. And what it saw inside that coma was not what anyone expected. The infrared spectrum came back with carbon dioxide, carbon monoxide, water ice, normal, exactly what you'd expect. But underneath those signatures, buried in the mid-infrared range, something else appeared. Complex organic molecules, long-chain structures, the kind that don't form in open space, the kind that form inside something. Astronomers have a word for this: prebiotic chemistry, the raw ingredients that, under the right conditions, assemble into the building blocks of life. We've seen traces of this before in meteorites, in deep space clouds, never in an interstellar object passing through our solar system in real time. Now pair that with the trajectory data. 3I/Atlas did not enter from the galactic plane the way most interstellar objects do. It came in at a steep angle, from above, from the direction of the constellation Lupus. There are no known stellar nurseries in that direction, no obvious
obvious origin point. No star it could have been gravitationally ejected from at a matching velocity. Run the numbers backward and you don't find a home. You find an empty corridor between stellar systems that it has apparently been traveling through for longer than our models comfortably explain. And then there is the rotation. Light curve data from ground observatories shows almost no variation in brightness as it tumbles. Most rocky bodies wobble. Most cometary nuclei have irregular shapes that catch light differently as they spin. 3I/Atlas is either nearly spherical or it is not rotating the way a randomly shaped object should. Neither answer is simple. So what is it? The leading scientific position is still natural origin, an ancient body from the early galaxy, rich in organics because the early universe was chemically active in ways we are still mapping. But there is a second position gaining quiet traction in preprint discussions, that the organic complexity is too structured, that the near-perfect light curve is too clean, that the trajectory from a directionless corridor combined with a Jupiter gravity assist that added exactly the right velocity to pass through the inner solar system is a sequence of coincidences that deserves harder scrutiny. No one is saying it out loud in a press release, but they are saying it in the data sections of papers, in the careful phrasing of conclusions, in the things that get flagged as requiring further observation. The James Webb Space Telescope was not built to find interstellar visitors. It was built to see the first light of the universe, to find the atmospheres of distant worlds, to look at things billions of light years away. When it turns that instrument on something 1.8 AU from Earth, something that will never come this close again, and the result is a spectrum that researchers are describing in internal communications as anomalous, that matters. 3I/Atlas will be beyond Neptune's orbit before any mission could realistically reach it. There will be no sample return, no close flyby, no second look, just the data we collected in this narrow window from a telescope that almost wasn't pointed at it in time. And in that data, a chemical signature that does not sit quietly inside any existing category. Not a comet, not quite, not an asteroid, not even close. Something old, something traveled, something that passed through our solar system carrying molecules that took more than gravity and cold vacuum to build. The question astronomers are not asking publicly, but are absolutely asking privately, is this: was 3I/Atlas the first one we actually looked at closely enough to notice, or just the first one we were willing to admit we didn't understand? Want to be notified when Claude responds? Notify.